Hey, how's it going, guys and gals, and everyone else out there? Yeah, thanks for coming by, and I hope we got a few people here to ask questions. We, you know, chat, and might be learn a few things about fighting game development. How y'all doing out there? Yep. Well, yeah, it's a fine Tuesday out here. I know it's still out there. It's in the States is Monday, but hope you're having a good week already. And I sure am. I got my coffee, did a bunch of work this morning, so I got pretty far ahead of what I need to do. Hope it's working out for all y'all. Okay, awesome. Well, I'm just gonna sit here and chat. We can, hang until we got more people coming in, and then I'll get started here. Yep. Well, for the people who are already here, any questions, anything you're curious about, I maybe can answer or give you some insight into. I'd be happy to do so. Alrighty. Let's see. Awesome. Okay, I guess y'all can hear me just fine. Is my assumption here? Awesome, awesome, possum. Okay, well, for y'all who are already in here, let's take a look at like what we were doing last time and kind of go over what I plan to do here. Now, let's see. Okay, well, just a quick look at our change list. We pretty much just added support for positive edge inputs. And as you've recalled, that just means we detect when the input changes, and all we needed for that was record the last frame's input, and look at the current frame input and see if there's a difference. And that was for positive edge inputs. There's also a concept of negative edge inputs when you release a button. I could add support for that, but today I won't do that. I'll just focus on input buffering and special move inputs. All right. Yeah. And I just want to take a quick look to see if there's anything that we want to improve upon or change before I go forward with special moves. Okay. Yep. Alrighty here. Okay, this is just our change list from last time. You can see like we added this new component, input component, to our context for all the characters, right? Um, input component already existed, but it wasn't like consistent with the rest of the components, so I just went ahead and did that last time. As you probably recall, we added these several functions like that actually updates the current input based on the current buffer index, which again, as you recall, it's a ring buffer, which just means we have an index that cycles between 0 and 1 for this case, but actually we'll extend that here in a bit to support special move inputs. This allows us to just detect changes in input, so we can see when it was pressed. And we added functions for like getting current input and getting last input, and detect to detect if the last input was pressed. We just do exactly what I said. Like if the current input is set and the last frame's input was not set, then the input was pressed. And we could easily do something similar for released. And I won't necessarily go through the steps of implementing that here, but that's the case. And you notice we don't have pressed for up, down, left, right, back, forward. That's easy enough. It basically just follows with the rest of this. And I could just do that right now just to get warmed up here. What code file was that in? That was in component.zig. Okay, component.zig. So I'm actually going to just go through this without testing it, which is not necessarily like best practice, but yeah, it is what it is, I guess. And honestly, we could just, instead of like calling this every time like this, because it gets very verbose, we can just go, I think in Zig we just go blah, 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 blah. So we can say like, what do we call it? Current input equals this, and then input equals this, right? And then we could just, you know, again, just kind of replace this with this, right? That way, when we come through and we have to update this later, potentially we don't have to rewrite all this stuff, right? And this is going to make this a little more clean. So, yeah, again, current input and then last input. And yeah, we can just copy that for everything, and that's going to be up, right? It's going to go through here and update all of them real quick. Down, down, left, left, right, right, back, back, sorry about that, and forward, 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 forward. This can come useful for starting kind of special move inputs, actually having a positive edge check for those, but for the most part we won't be using it, right? Because most of the change inputs we want to detect is when you're like pressing a button for an attack. Okay. So hopefully that works. Let's just build it real quick. Okay. Positive input still works. Great. Awesome. Okay. Let's go over a little bit of what I plan to do today after talking about that. So what the, I thought I had stream notes. Okay, here we go. Yeah, so just a bit of a review, and I want to go on to like detecting motion inputs real quick, and then we can get forward with implementing special moves, right? Cool. So first of all, like, what do I mean by special move inputs or motion inputs? What I mean is things like Ryu's Hadouken requires you to do a quarter circle forward, which, you press down on your stick and then down forward, and then like that. So you'll press down, forward, and forward, and then a punch button, right? And that gives you the Hadouken, right? What does BG Close to say? Hey, I don't really know anything about system languages, but I feel like I've already learned a lot in 5 minutes Googling what Zig is and realizing how many languages are based on C. Yeah, I mean, Zig is definitely based on C. It's trying to be an improved C, slightly different syntax, some like more like modern conveniences. Zig is cool. I recommend learning it. It's still kind of a work in progress, but it's fairly stable. And I think once they get their self-hosted compiler in a good place, it will be ready for production. Yeah, a lot of languages do take from the C syntax. It's just because it's pretty straightforward, and C is not that complex of a language. There's not a lot of like syntactical things you need to learn. It's mostly like, since you're doing low-level stuff, you need to know how to work with like raw memory and such stuff like that, and not blow up your program, blow up your computer along the way. Okay, well, yeah, going back to special move input. So yeah, as you saw with like Hadouken, right? We're gonna have like, I'm gonna do that. Down, forward, and punch. And when you execute this input on your stick or on your gamepad, right? To demonstrate here, right? I don't know if we can see this clearly. Yeah, probably be better if I do this. You press down, forward, and then forward, and that's a motion input, right? You do that in a sequence. Not only do you do it in a sequence, you need to do it within a fixed amount of time. You can, if you do this, hold it for a second, then down forward for a second, and then forward for a second, press punch, you're not going to get the special move input. You're not going to get the special action to come out. So you need to do it quick enough and then press the button to get the special move. And that's what we mean by special move inputs or just motion inputs. So that's the thing I want to implement. So there's a few other concepts with it, which is that because fighting games tend to be symmetrical, you can face left or face right. We have the convention of forward is to the right. So when we write out this notation like I was showing here with down, down, forward, and forward, it's always under the assumption we're facing right. This would be reversed for left. And in code, I'll always assume forward is to the right. Left is the exception, and then we have to invert all the inputs when facing left. Now, there's other examples of special move motions, right? There's like Ryu's Hadouken, which is very common motion, and like most special move motions seem to be that style. But there's also his like Shoryuken, right? His Dragon Punch, which is forward, down, forward, forward, down, down, forward. So it's like this, right? It's a little tiny here, forward, forward, down, down, forward, and then a punch button, right? You know, this will be a Shoryuken or Dragon Punch, Dragon Punch, or Hadouken, yeah, or Fireball, right? Same thing. There's no difference. The only thing that changes is the sequence of directions and potentially the timing of it. There might be a different limit on how long you have to press these inputs in sequence, depending on the game. There's many versions of Street Fighter, many games that use the same inputs as Street Fighter, right? So, yeah. Okay, hopefully that concept is easy enough to understand. And before we really move on with implementation, I do want to bring up a few other things. The first thing is, well, we could use Unicode to write arrows as our symbols for the directions, but really don't want to do that, right? It's not easy to type. I'm only able to type it really easily because I have Japanese input, which lets me do it pretty easily. But typically, when fighting game players do communicate with each other, they write things in what's called like numpad notation, or the number pad. If you just look down at your keyboard, and not everybody has it on laptops, but I'm pretty sure you know what a number pad is. We use the directions starting from 5, right, up, down, left, right, where 8 is up and 2 is down. I guess I gotta just write out here for you. So this is like the numpad layout, right? And this is going to be equivalent to the cardinal directions, right? Like I'm just gonna, hopefully it'll all line up here. And I know for some of you guys this is just straight up like common sense, but I don't know if everybody is aware of how common this is in fighting games or not. I'm going to put in here for neutral, and then yeah, hopefully I can line this all up. I'm getting a tab here. Doesn't like me, does it? Yeah, I don't think I have monospace font, unfortunately, here. But I think you all get the idea. Let's see. And I don't know if even if I use a monospace font, would it work with Japanese here? Not sure. Okay. But I think that's you kind of get the the gist here, right? Where, like, each of these characters is associated with these numbers, and which means it's this direction, right? So 7 would be back up into the back, 9 would be up to the forward, 6 is forward, 4 is back, etc., etc., etc. In here just means neutral, means no direction, so, and 5 represents neutral. So how, interested in how 2.2 and 6.6 inputs will work since they require return to neutral. Yeah, so I don't know if I'll cover that today, but it does involve positive and negative edge inputs. So you'll have to detect whether a move was input was released or pressed again. Okay, so hopefully that concept makes sense, right? So the reason why I had to bring this up, and like I mentioned before, is we're not going to type arrows into our code, right? We're going to use numbers to quickly like encode what we mean by special move input. So for example, the the Hadouken motion, right, would be represented by down, down, forward, forward. And in numpad notation, we'd write it as a sequence of something like this, like 2, 3, and 6. Right? It'll be a sequence of 2, 3, 6. And that's the way for us to write in code easily what we mean by, the fireball input. And then, of course, with the Dragon Punch, right, similar thing. We'll just do, forward being 4, down being 2, and down forward being 3. Okay. Hopefully that all clicks. Okay. So there we are. That's kind of the idea, and gives us kind of a direction where to do things in code. So just to kind of give you a little preview of what I think we need to do here is, first of all, to actually track all these inputs, right? Well, we only have 2 frames for input buffer at the moment, so we're going to have to make it go longer. We're going to have to make it at least as big as we need to store the longest sequence of directional inputs for any particular special move input we want, or any motion input that we want. So to actually record and detect a quarter circle forward motion, I'm sorry, I should write out what we mean by like these motions. Let's say like we often write Q, CF, or quarter circle forward for this. And I'm just going to point this out because I might comment code like this. So I might say, and then we might say DP, we mean Dragon Punch. It's often name we give to these motion inputs. And there's similar things for like quarter circle back, right? So we got, oops, we got that, and can't type here. Okay. So yeah, 2, 1, 4 for that, right? So, oh, sorry, I actually messed up here. This shouldn't be 4. This should be 6. And sometimes I'll do like reverse Dragon Punch in my code. So I'll have like, oops, I'll have like this, right? And I'll just like notate that as like reverse Dragon Punch, RDP or something. There's like other names for like Dragon Kick or whatever. Just don't. These are just like convenient names to give to things. Yeah, thank you for Flake Lows for pointing that out. Yeah, if anybody ever sees a mistake with this stuff, just let me know and I'll quickly correct it. Yeah, and then quarter circle back. Right. Okay. Well, yeah, this is not monospace. Okay. Yeah, there we are with that. And yeah, the kind of strategy we'll have is we'll want to encode the sequence of numbers which represents the directions in a way that lets us quickly read each direction per frame. And yeah, the general idea is like, oh, if we look back in the input buffer and we see like the number 2, and then after 2 we see 3, and then after 3 we see 6, well, we can pretty much guarantee the player inputted or was trying to input quarter circle forward. Now, I mentioned before that this a buffer of 3 frames of input would be enough to actually detect that motion, but I hope the problem of only having 3 frames of input history is obvious. Like, that means you have to input 2 or down perfectly, and then the next frame you have to input down forward perfectly, and then the frame after that you have to input forward perfectly within 3 frames. You don't without skipping over anything. That's not ideal, right? So, right, if I just like kind of draw out the buffer here, right? So currently we have the 2 frame buffer, which is not enough, right? Say we just had like down and down forward. Well, we can't, that wouldn't work because we don't have enough frames for input. So we extend it to 3 frames, right? So that gives us down, down forward, potentially, and forward. Cool, check mark, we got Hadouken, right? Fireball comes out. And I'm just going to draw a little fireball here. Okay. Anyway, but as you can see, if you miss, right, if you miss the timing of that, and you do like down, for example, and then down again, and then you like somehow skip down forward, oh, that's going to be bad. It's going to be no good. So it doesn't come out. You failed, right? So we're going to have to add some way to have leeway here, right? Well, the kind of first thing we think of is like, what if we just kind of like make the buffer bigger, like much bigger, right? And that way, we can have a lot of frames to give you to execute all these directions in sequence. So I'll say do down here, and then I do down forward here, down forward, and then forward here, forward here. It's not an earthquake, is it? Okay. I think people are just moving upstairs. Okay. I don't know if you saw the camera shaking or anything. Okay, well, in cases like this, we want to support executing the fireball, right? So, cool. Fireball. So this is going to give us leeway on executing special move inputs. Now, there's a case where we don't want this to actually execute, right? We really do care about the order. So if you do like down forward, and then forward here or something, and then down forward, and down or whatever, this is going to be no good. I know for a lot of you this is common sense, right? If you play fighting games, most of you know this, but if you don't, I just want to record this for posterity's sake. And that'll give us enough leeway to actually make it easy enough for players to actually execute these moves without being too difficult. It has a restriction in that you have to do the sequence of inputs in order, but you don't have to time it perfectly under 3 frames. And in fact, I'm going to make the input buffer really long, because there will be reasons for that. Like there might be inputs we want to last for a whole second. Those kind of inputs are called like charge inputs, right? So in concept, you would hold back, and then there's some time that executes, and you hold forward, right? And then you get like a headbutt or something from Honda, you know, in Street Fighter. And conceptually, that buffer would look something like you're holding back. Sorry, let me draw it's a lot of frames. I'm going to do this, and I'm just going to dot, dot, dot to indicate it's the same thing. And then suddenly you're holding forward, right? And that gives you the headbutt. Oops, headbutt. Headbutt. This is a charge motion, right? Charge. And conceptually, this could be as long as you want it to be. But I'm just going to say, like, oh, maybe there's like, it needs to be 30 frames or something. And in the case of the charge moves, we'll have to actually track, instead of making sure you've inputted something within a fixed amount of time, it needs to be at least a certain amount of time. So kind of the opposite of detecting quarter circle motions of these type of. So these are kind of different type of motion inputs. Today, I'm not going to cover this one, but I just wanted to give you an overview of what will be required to support it. Okay. Just going to give you an idea what the goal of this series of videos is for. It's mostly for like recording all the weird edge cases and stuff that pop up in fighting games you may not think. It might not be obvious, right? These kind of things. And I really want to record this stuff on video as much as I can. I'm not trying to be completely exhaustive with all the things that are used in fighting games, but maybe in the future, as an addendum or something, I'll add additional videos to explain things like how do you implement a charge move or whatever. Okay. I think we're good on pretty time here for going over the concept of special move inputs. Okay, I think the next thing you want to do here is actually get to the point where we're implementing it. So the first thing we got to do is extend the length of the buffer, input buffer. And while doing that, I want to make sure our existing code actually works. But before doing that, is there any questions related to what I just explained with the special move input buffers and things like that. Okay. Okay, and I believe our buffer size is set in the component zig file, if I'm not wrong. Yeah, so we have an input buffer size of 2 right now. I'm going to extend it to 60. And hopefully with the way we already implemented this ring buffer, it will just work. We don't have to worry about the buffer size affecting whether or not our positive inputs work. So I'm just going to go ahead and execute that and see if our positive edge inputs still work. Seems to be the case. Oop, and I just fell through the floor. Well, at least that bug is on the video, so I know I can go back and see what the cause was. Oh, holding back is the cause. Okay, cool. That's for you, future Zynek. Okay. We'll go fix that later. Yeah, it looks like if you attack and hold back, it happens. Yeah, that's it. So attacking and hold back is the bug. Okay. It's important to take notes and record this kind of stuff because you might forget and you may not remember to go and fix it later. Okay, yeah, so it looks like our input's working. That's fantastic. Okay, cool. So the kind of the next step here is we need to like write the encoding, right, for our directional inputs. And I mentioned before we're going to use numpad notation. But we also kind of need a data structure to store that. And we're also going to need to store that per action so that the action can indicate, hey, okay, this is the move, the special move input we need to actually execute this move. So it's going to become like conditional for transitioning into that action state. Right now, we don't have any conditionals other than the positive ed input check. So like last time we added this function was input pressed, right? And it's only called here in our state transition, a common attack transition. So I just do a little bit of exploratory coding here. I could also like add something like this, right? So instead of going to this attack state, we could have like a special state here, which we haven't implemented yet. Actually, this is a special move name, so it wouldn't be this. We might have like conceptually, you might have an input, motion names, and let's say quarter circle forward, right? And there's a reason why I mentioned this earlier, because I like to name things like this. So it won't be was input pressed. It'll be something like was motion executed, right? And we'll just check that. But we also can add an optional parameter. Say, hey, we want the motion input to have been executed within 15 frames, right? So this conceptual function would go through, detect those sequence of inputs, and see if they occurred within 15 frames, right? But actually, one thing is missing here. We don't care about just the motion, right? We also care about the button being pressed. So we want to see if the attack button was pressed and see the motion was also executed. Because we don't want the attack coming out just because the directions are pressed, right? So they would execute that. Instead of like transitioning to attack, we want to transition to our special state. We don't have a special state, but we'll implement that. Okay. So, and we want the special to have priority over attack, because otherwise, well, if you press attack, if you press the attack button and this was executed first, you would get this the normal move instead of the special move. And our previous attack will consider the normal move because it doesn't require special move inputs or motion inputs. Okay, so we need to implement this was motion executed. We need to implement, we need to add names for our special move inputs, our motions, like quarter circle forward. So I'm just going to go to this definition of this. Oh, it didn't jump there. I think that's in our input file anyway. So we have these input names. Let's make a new enum called motion names. And we're going to give some common ones for now, right? So I'm going to do, oops, let's do, okay, quarter circle forward, quarter circle back, and DP and reverse DP for now. Okay, and I'm just going to, just to comment these, make it obvious what those are, I'm going to look in our stream notes and copy those diagrams. Okay. So we're going to support 4 motions here this time around. Okay. Hey, what's up, Pete? Thanks for coming by. Definitely appreciate it. Okay, so we got our names for our motion inputs. That's awesome. But we also need to encode them somehow. So the way I'm gonna choose to encode them is we're gonna make a new array that gives us a sequence of what inputs this is for, right? So this would be 2, 3, 6, 2, 1, 4, 6, 2, 3, and 4, 2, 1. Okay. And I'm trying to remember here in Zig, how can I define a const inline array? Well, in C it would be something like motion inputs, I don't know, equals, no, it wouldn't be like that. It would be something like, okay, something like this, right? And then we'd have like, oh, sorry, it'd be const int 32, something like this. I'm just brainstorming here, sorry. And we motion names at length, and there'll be, ooh, okay, motion inputs, and you would do something like, sorry, it would actually be, I think in C it would be something like this. I'm just, again, just brainstorming here, and I'm gonna come in and like fix this for Zig, because I don't know what way to do it in line like this for Zig is. Oh, my brain is. This actually may be C++ only, not C, but that's neither here nor there. We're not going to worry about it too much. Alrighty. And then DP would be like, again, that would be 6, 1, 6, 2, 3. And the reverse Dragon Punch would be 4, 2, 1, right? Okay. And that would be C. That's just the C example of what I'm trying to do here. So I'm going to go ahead and close it out real quick. And I need to figure out real quick what that would be in Zig. You know, of course I can make a dynamic array and add these sequences to it, but I'm not going to do that for now. And in fact, we don't really need to make it int32, but just for convenience sake, I'm doing that for now. Have I have I done a big inline array like this anywhere in code? That's a good question. Well, blah. Let's see. I probably did something either in the state machine. I'm just looking for examples, and also have my Zig notes. I forgot. So, what do we have for our array notes? Okay, so like a const message looks like this, right? The question is it easy enough to do like an array inside of an array, or is it going to complain? And well, let's just give it a shot, right? I don't like to get too bogged down in this kind of stuff, but we'll do our best. So it looks like the format is like this. So we have a const motion inputs, I32, that's fine. But instead of like this, I want to have each of these be a sequence. Okay. So we're just going to start off with 2, 3, 6, 6. 2, 1, 4, 6, 2, 3. It's complaining right now. So I don't know if it's actually going to compile. Oh, I probably have to do something like this. Does this work? No, it doesn't work. Okay. what does it say? Expected semicolon found comma. So yeah, that doesn't necessarily work. Let's see, what do we have here? So how do we do an array inside of an array in Zig? Anybody know? If you don't know, it's cool. We can look it up. It's all part of learning. So a two-dimensional array in Zig. Let's see what that is. Two-dimensional array Zig. Multi-dimensional array Zig. What did it do? From okay. Also, you have to individually write this kind of thing. You have to actually be explicit about the type. Okay, I got it. That's cool. So I guess that means it needs to look like this and I32. So did we need to do the first one? Okay, that's fine. And let's just copy that here. Do I remember the input command for doing? Oop, that's not it. It's like this. Yeah, there we go. And did that work? I'm still complaining. No, unable to infer. Can't infer buffer size. That's fine. So let's do motion names dot length. Does that work? No. No member name. No member name was motion executed. That's fine. Okay, cool. So that was the issue on that in our component. Was motion executed? Oh no, that's in our state machine, right? Oh, where was that? I think that's in our common states. Yeah, let's just comment this out real quick and see if we compile. Luckily, compile is so fast we can learn from just compiling, right? Okay, cool. So let's go ahead and just add our functions, even though we're not necessarily going to implement it yet. We want to have it there as kind of a placeholder. So where's our component? So instead of what is input pressed, now we want to have a was motion executed. Okay, and then we add our input component, and then we need to have motion name. So input dot motion names, and then we want to have time limit or something, right? Oops, that's a C style time limit. Time limit. In 32. U size might be better, but it's actually gonna be I32. Sorry. Okay, and we're just gonna return false until we implement this. So it's gonna fail until we make it work, basically. Okay. That's cool. So that works. We have course to go forward. We don't have a special move yet, so we need attack. We need an attack. So oof. I forgot all the steps we need to implement our new states. Is it? Yeah. Okay. So let's just copy attack and call it special. And we'll say on special start real quick. There's probably something at compile time I could have done to print out. Just let me type. There we go. Yeah, it's probably something we could have done there, but anywho, we've implemented special, so at least it will print out special once we get everything working. We probably need to actually specify our functions though, because I think this wasn't an automatic thing we did like a compile time. We actually had to specify these things. So I think it was like attack dot on start or something. Yeah, so we have to do this. We actually have to make a copy of this whole thing. So we have attack callbacks and we have special callbacks, and we have to register them. Again, this wasn't the most elegant thing, but easy to copy though. So name is special, and special. Probably again, I could have basically automated a lot of this using like compile time execution, but whatever. We'll deal with it in the future. Just gotta make progress. Sometimes you only know how to go forward one way, and that's what you gotta do. And then you correct it later. Okay, so we have the special move there. There's one thing though, we don't actually have a special move in our character data, so we'll have to make a copy of the existing character data. I don't think it's test one. I think it's is it animation, or maybe it is test one. Okay, then we have attack. Is that the attack? Yeah, this is the attack. So I'm gonna copy that, paste it, and I think let's call it special. And I made a new image for this, for the animation. So you see there's a timeline that's like this. I'm gonna make a new timeline that's like special. And what I'm gonna do is copy the existing timeline for attack, this one, make a new one. Just, if you recall, a timeline of images is just a sequence of images that we name for convenience sake. So I'm just going to use the existing attack zero animation. I actually made an attack, a special animation like this for the attack frame, and we'll just reuse this. Okay, so we have those all working now. And what I'm going to do here is go in and just to see if that action comes out, right? Currently we have what is it? Was input pressed here? So that's going to go false, but I'm just going to go ahead and add special here to see if the special comes out when I press the attack button. Oop, did I miss something here? Time limit, unused function. Oh, that's right. So let's see. Component, time limit. This is unused. So yeah, I need to actually just for now do. I think this is the way to do it. You can do like self and motion name and time limit. Does that work? Does that work? Or I have to do them all separately. I forget. Yeah. Okay. So I have to do all separately, I guess. Self. There's probably some way to do it. I just don't know. Whoop. Equals. This is make sure it ignores that error where it's like, oh, you're not using this parameter. Fine. What's the issue here? Error, a combat state ID has no field matching special. Oh, I forgot about that. Okay, let's go to the state machine file and fix that. Combat state ID. Okay, we have attack and special. So a lot of boilerplate. And honestly, we try as much as possible to not have this much boilerplate in code. As much as you can, you want to automate this stuff, right? Extract things away and just automate it. The build failed with what code? I don't know what code that was, so I'm gonna hopefully it will work this time. Error. Input name says no member called special. Oops, so I did something incorrectly. Okay. Common states. There we go. Input names at line number 60. Oh, that's the problem. It should have been not this. This should have been the input is attack input, right? But we want to execute special. That's what I want to test. And then it crashed. I don't know why it crashed, but it did crash. Maybe it's this code. I don't know. Let's comment it out. If it still crashes, it's not that code, obviously. It did crash. So, it's in the game loop. It's in the game loop. Where did it crash? JSON. Oh, it's my JSON code. So, I did something to the JSON code that was invalid. Let's jump in here. I probably forgot like a curly bracket somewhere or a comma somewhere. Who knows? Let's look at a diff of this file. So I probably can just do that real quick. I can look at our JSON diff. Look at changes. Okay. So, ooh, that looks right. I think that's right. That's right. That's right there. So, what did I forget? Oh, I changed something here. Special to attack. That's okay. Jump special. Oh, I messed up here. This should have been named special. Right? And this should be named attack. I didn't want to change that actually. So I forget. It doesn't look like I forgot anything necessarily. Maybe I forgot it here. I don't know. Let's try to run the game again. That's really strange. Maybe it was looking for something and missed it. No, that's not the case. Arg. Okay. What am I missing? I might get some indication from the error log about what JSON choked on. Yeah, so it choked on unexpected end of JSON. Okay, so that means I'm missing a bracket somewhere. for these changes. So I added a bracket start here, add a bracket in there with a comma. Okay. This is just a copy, so I shouldn't have had an error here. So there's an error up here. So, sorry. There's that one, and there's this one, and then there's this one. What am I not seeing? Did I forget a... What am I missing? Can I analyze a JSON file and tell me what's wrong? JSON... What is it? JSON preference. There's any like things that let me open JSON. Inspect key mechanism. You know what? Let me look. Is there a JSON validator? JSON validator. Is there any problem? Linter. What is what's the issue with my JSON? What's the problem? It says it's valid. So what's the issue? That's weird. Maybe something in the parser for Zig is choking on. These kind of problems you just don't want to run into. Not really. Okay. So this is my code. Parse message. Okay. And it's just trying to tokenize it, right? And we got an unexpected end of JSON, which means the JSON file oh, I think I know the problem. I forgot we don't dynamically sizing our buffer for storing the JSON. That's the thing actually I intended to get to at some point. So I just need to increase the size of the buffer. That's it. My bad. I'm surprised I even remember that, to be honest. Yeah. So where's our buffer? Forgot what it was. Buffer. Yeah, you see this? Load asset. I only have 4 times 248 bytes. I'm just going to increase that to 16. Should fix it. Again, this is kind of dirty stuff, but I wasn't trying to be exhaustive with our code, and that did fix it. Okay. Alrighty. Yep. And it looks like the image is missing. I thought I added that image. Let's double check this here. So we should have it in our assets, color 1, special attack 00. That's the attack I was looking for. Okay, so let's do this real quick. It was special attack, not special. Okay, there we go. So that now we should get it. At least we know the action's coming out, right? There we go. Whoa, offset's completely wrong, of course. I would have to fix the offset real quick, but we're gonna ignore the offset for now. I can go in like adjust that. At least we know the special move can come out. That's the most important thing. Got to validate that before doing anything else. It's always a sequence of cause and effect that we can validate, right? The first thing it's got to check to see, well, can we get the move to come out? And it does. Now we can move on to the motions. Okay, so we did that in our common states, right? I'm gonna undo that. It's going back to attack. So now we want to validate special move motion. So let's just go for the first naive approach that we think would work, which is we're going to step through our input buffer and see if each of those motions, each of those directions are coming out. Okay, so of course we're going to need a for loop, right? So we're going to need a for loop here. And I forgot the syntax for Lua, not Lua, for Zig, for loops. So that's what our notes are for. So I think the format's like this. You pass in a value. It's like that. Okay, so just a naive approach real quick. We're just going to go and do it. So what we want to do is actually go for self.inputBuffer. We're just going to go through everything in this. And we're going to pass in the input command. Okay, and it's going to look, this is kind of rough shape of kind of what we're looking for, right? So the rough shape is we want to see if that input command is equal to some like value of in the motion. So actually we need to also get like the input. I thought we had motion sequence or something. Where did that go? Motion inputs. Yeah, it's like I didn't make that public. That's why. Okay. So kind of the rough thing is like we want like motion inputs. We need to actually get this so actually what we want to do is not loop over the buffer necessarily. So yeah, one approach we can do is every time we detect an input that's like at the beginning of the buffer. So actually I should draw this out conceptually. I think visually makes a lot more sense, right? So let's go here. So what we actually want to do with the loop, right? We have the input buffer, input buffer, input buffer, right? You know, we have these sequence of inputs per frame. And we want to match this against our motion list, our motion inputs, right? So conceptually, we're going to go through this one by one, right? And then every time we, every time it matches, say, oh, it doesn't match. Oh, then it matches this one, right? We just check it off. Oop, it matched. Then we go on to the next one. So we start with here, looking here and looking this one by one, and then we go to the next cubbyhole, the next slot, and then we check to see, oh, does it match, doesn't match, doesn't match. Oh, it matches. Then we check that off, right? Again, this is conceptually. And we go through, and we find another one that matches, and we see that we've matched all the inputs, and then we're good, right? That's conceptually what we're doing. I hope that makes sense. We just need to implement that as code. That's how we're going to do our matching. There's a lot of different ways you can do this. Sometimes I do backwards search, so I start at the end of the motion input list and go through the buffer backwards. Sometimes I start from the beginning and go forward. There's actually another aspect. We need to make sure that this sequence is less than, so the length of this is less than our time limit, right? So that's another condition. If we exceed that time limit, we immediately know we failed on checking. The thing is, though, we need to make sure that it comes from the end of the buffer, not the start of the buffer, because the end of the buffer represents our current frame. So another trick you can do there is you don't actually have to keep checking that. You can just go to X number of frames before, that's the time limit, and go forward. So then you just forget about checking the time limit. This is kind of a shortcut. So to represent that, let's start making a variable that's let's make a variable that is the an I32. So we want to go buffer start. This is going to be the first frame we check inputs. So buffer start is going to be equal to our current buffer time. I think it's what, self.input buff. Is it buffer index? So we're going to start the buffer index, and then we're going to subtract our time limit. And just a quick sanity check here. Sorry, I'll make that a usize. Probably I need to fix this to be usize as well, because I think the buffer index is usize. So I want to make this usize. Otherwise, Zig will complain, I know how to do conversions, and I'm annoyed by that. I won't do that. Okay. So we have a buffer start, which is time limit number of frames before the current index. If the time limit was 0 frames, which means it would never work, it would just be the current frame, right? One frame would be one frame before, et cetera, et cetera, et cetera. This would be fine, but remember, we're on a ring buffer. So the first thing is, if this buffer index my time limit is negative, then we're past the start of the array, right? And we want to wrap around. So the easy way to do that is to get the buffer size. So buffer, we kind of did this trick before, right? We get the length of the buffer. We add on the end of the buffer index. And we subtract the time, right? And then we do the modular trick. So we don't actually technically need these parentheses, so I'm going to get rid of that. And this lets us wrap around. Just do a quick sanity check with this. So we have this will give us 0 if we wrap around, right? Because it's the length of the buffer, and the remainder divided by the length gives us 0. Then we add the current index, and then we subtract the time on it. Okay, cool. The only issue that comes in is that if this is actually larger than the buffer length plus the index, then we get a negative value. But for now, we're just going to kind of ignore that that case. I can make it more robust and do a check here, right? So I would have to do something like, we could do something like if time limit is greater than. There's probably some way to avoid this, doing this kind of thing, right? If I can say if this is greater than this, and I might have it off by 1 error here. I can go back and correct it. I'm just trying to get everything conceptually down. Then we just say you can't check longer than the buffer, so we're gonna return false and say we didn't detect it. Or the other way around is we can just limit the buffer to this size, right? So the time limit's longer than the buffer. Then we could just say, instead of returning false, we just go, hey, null time limit is going to be equal to, can I make it this far? I don't know. We can say, I don't think we can do that in Zig, but we can just say the time limit is equal to this, right? So that would do that. Or another way to do this, instead of doing that, is we can say the buffer start is blah, blah, blah frames before. So we're going to get plain. Oop, I have that error there, so Anyway, let's comment that out real quick. See if it complains real quick. Yeah, unused local variable, it's fine, it's fine, it's fine. Just to see if this compiles. I actually didn't realize we can actually overwrite that, but cool. We can do it. How are we doing on time here, guys? Okay, about an hour in. I was planning to do about an hour and a half today. It's a little longer one today. Error, cannot assign to constant. That's what I thought. So I had to do all this stuff before this error came out. So I could just read, and I can clean this up later. Right. And then I'm going to say, is it going to play? What's going on here? Can I assign to a constant? I'm not trying to assign. Oh, it's just old. It's not updating that. Okay. Sometimes I just do first pass naming on this stuff. Okay, that works. Oh, cool. So now we can actually go through and do all the checking stuff. So we know where we're going to start in the buffer, and we're going to go forward and check to see if we can match all the inputs. So what we want to do is actually have an index that checks that keeps track of the current motion input direction that we want to check. So let's just say current motion index, right? And make it a U size, and it's going to start at 0. And when we loop through here, we're going to match it. Conceptually, we're going to match up, and then every time we get a match, we're going to increment this current index. So when we get a match like this, we'll do like, okay, current motion index equals current motion index plus 1. And then if motion index is greater than or equal to the size of our list of inputs, which comes from somewhere that we need to get, yeah, it'll be yeah, it's going to be greater than the motion inputs, and then we'll say, okay, everything matched, return true. Right. Otherwise, it's going to fail and return false. So we need to fill in these parts, right? So I'm going to first do this, because I don't know how we need to do a conversion between our numpad inputs and what we actually have recorded in our input buffer, because it's recorded in a struct. It's not recorded as numbers. So that once we do that and we do this, we should be done. And I think that's where I'm going to end the stream today. We can come back and talk about improvements next time. Or if we have a little bit time left, I'll go over it. Okay, so the first step is we need to actually get that list of motion inputs, right? Well, we know we have them in, I think it's input dot motion inputs, right? And we need to take our motion name and we need to convert it. I think we'll have to, I don't know if we get an automatic index from this. Well, we'll see. Let's see. Let's just call it a motion list or something. And let's see if the current motion index is greater than motion length, the length of it. Great, returns true. So we go through here. We need to do a conversion, right? So before we do a conversion, let's just see if this compiles, because I'm lazy. Not lazy. I don't want to make sure I haven't made an error yet. So unused capture. Yeah. Okay. It's going to complain about that. Okay. Yeah, I have unused capture. What is there any other issue it's going to complain about? Container image has no member called length. Motion names does not have length. Why doesn't it have length? Oh, let me go ahead and do that real quick. Why doesn't it have length? Motion names has no length. That's at number 65. Wait, what? Container input has no member called length. Oh, 41. Not okay. Whoa. Oh, okay. 65 input motion. Is it because I'm trying to pull? Oh, because it's not an array, right? Okay, how do I convert? What? Hold on. It should be an array, right? Oh, motion names doesn't have a length. Oh, so now it's complaining about this, so it doesn't have a length. Oh, okay. How do you get like the largest value of an enum? I think, if it's okay, I need to double check on my enum stuff because I don't know about Zig. So it covers value. Okay. Okay. So we have enum. We have int to enum. Do we have enum to int? Oh, okay. So let's just guess that this is gonna work. Okay. So in our input code, yeah. So what do we do here? So that doesn't work, but maybe we can do. That's not what I want. Enum to int, and we're going to convert motion names dot RDP. It would be nice if this was last. So actually, one kind of trick we could do, I think, should work. We can say last, which will be unused, but it'll let us add more later and not worry about that. That might work. I don't know. That should give us like the length, because if this is 0, 1, 2, 3, 4, 0, 1, 2, 3, 4, they'll give us a length of 4, which is what we want. Okay, so it is complaining though. I'm not sure about what. That's fine. Okay, it's still complaining about the last error. It hasn't like cleared that. Use undeclared event for input command. Okay, so that's the wrong input. Oh, there we go. There we go. Error, literals of things. Okay. Now it's saying error expected 4, found 3, literal. Now it's complaining about these errors. That's one thing that happens with Zig. It doesn't find errors unless you're actually using the code. It basically, the error doesn't exist unless the code is being used. Now it's being used. Now I'm seeing these errors. So, expected a 4, I3 literal, found a 3, I3 2 literal. So why would it expect a 4? I think it expects a 4 because this shouldn't be here. It should be this. I don't know if I can have, no, I probably can't have different sized array sizes here, so I'll just have to make it a fixed size for now. Yeah, so let's just make it a fixed size of 3 for now. We come in the future, we can re-implement this as something more robust. So enum to expected type use size found, motion names. Really? Hold on. Oh, that's probably that's the issue there. So that works. So we want to convert the motion name to a int, enum to int, Motion name. Is that gonna work? It's gonna work. It's gonna crash. Didn't crash. Sweet. Okay, so we just need to, honestly, so we don't have this check. It should just work if we press the attack button. Yep, it just works. Cool. So finally, we need to add the actual matching directional input to the motion name, which is just a number, right? It's just a number pad notation. So the easiest thing to do is have a function that switches on the direction. I believe that'll be the thing to do, and then we'll just check the inputs we need to check. So this is conceptually what I'm thinking. Yeah. Let's just make a new function here. I don't know if that's the best place to put it. And we say check. No. Let's not do it there. Let's do it in our input component with the other functions, right? So we're gonna make it a function right before here. I don't know if it's gonna be public or not, and also that it's not tabbed correctly for some reason. I don't know why. Okay. Yeah, let's make a new function. Not make it public yet. So if we want to pass in blah 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 blah. I don't know what to name it yet. check thing. I'll think about a name here in a second. So we want to pass in the input command, right? So what is the input command? The type, let's just say it's an input command, and the type is input command, right? And then we want to check, I don't know, in 1932, I don't know, numpad direction, and call it, not call anything, it just needs I32, right? And we'll have something that's like check numpad direction. Not the best name, but roll with me here. Okay, so we'll switch on the numpad direction. Oops. Pad direction. And we have a switch already, right? What's it? Switch can return a truth thing. So let's see. We can just return a switch here. And if it doesn't work, return false. Okay. And everything else is false here. First thing we do is we say we're going to go through everything. So one goes. What is the one check going to be? We want to see if they're pressed down back. Let's do the easiest example first and say 2 goes to input command dot. Oh, we don't want to do the input command. Sorry. We want to do. What is our struct? Is that input command? Also, it's not giving me the. Sorry. That's not doing autocomplete here. I messed something up then. Yeah, input command is what we want, right? So input command, input command, input command. Okay. Why isn't it like that? Expect a return type. Oh, we have no return type. Duh. Okay. That's the problem. So is it now going to complete? It's not going to complete for me now. Expected pointer dereference. Okay, has it become a pointer? That's fine, but okay. So 2 would be down, right? So if 2 means down is currently held, that's what 2 checks. Expected, oh yeah, returned that. We want to return that down is currently held. Expected comma after switch prolonged. Oh, not semicolon, right? And that doesn't work either. Oof. Okay, and then our follow through, I think, is this. Is this going to be false? Or we want to return false. We don't need to return. No. The value just needs to be this. It doesn't need to be a return. We just need to have this is how Zig works. So it's just going to be equal to false. And we don't need the semicolon. Expected, oh, not equals. Sorry. Syntax is this. Okay, so when you go through all the numbers we care about, 1, 2, 3, 4, 5, 6, 7, 8, 9, and yeah. We're gonna skip 5 because we're not gonna check. We could add 5 if somebody wanted to go through neutral, if neutral is required. I guess we could do that for now. And there's issues with that, but I'm just gonna ignore them for now. So 1, we need to check to see if both back and down is pressed, and we'll deal with flipping inputs later. But actually, we actually record if you're currently doing left and right at the time, but there's issues with, like, well, if the character was moving and they turned around, does the old inputs count as left or right now, or forward or back now? And I'm going to skip those issues for now and just roll with what I have, and we'll discuss how to solve those things later. So let's just assume it's left, not back, because I forgot exactly how and when we're going to record back and forward. Okay, so if left is pressed and down is pressed, because left by default is back, because we face right by default, and down, we'll return that, and not comma. Okay, and then the case of 3 is similar, but instead of left and down, it's right and down. I don't know, getting space there. Okay, and then 4 is going to go to input command back. 5 just returns. Well, we have to check to see if everything is not there, so I'm going to skip it for now. Basically, have to check to see if everything's false, right? I'm not going to do that here, as far as I'm lazy. Leave it as an exercise, is what they say in math classes, in college courses. Okay, so 6 would be forward, not forward. So I already made this mistake. This means left and right. 7 is going to be similar to what we had before. Here, instead of being like left and down, it'll be left and up. 8 is just up. Oops. Wish I was a faster typer. To be fair, these like symbols are kind of difficult to type sometimes. Okay, and then 9 will just be similar to this, right? But it'll be right instead of up. Okay. You could just make an array with the things you want to check. There's all kinds of ways you could do it depending on the language you're writing in, but yeah. Okay, so that gives us the check numpad direction, giving a command here. Now, honestly, we don't even need to have this inside of this function. We can put it inside our input file probably, yeah, because it's kind of agnostic to the input component, so we don't really care about being components. And we can make this public. Okay. That should be good. I don't know if you need to have this part here. I think that's fine. And then we just check it inside of our... So instead of doing this, we replace this, undo this, and we were checking, so we don't need to do this anymore. We don't need to check equals. It's something like input.check direction input, and we need to get the current input for the current frame, which was what, like get current input command? Yeah. So get current, we self get current input command, and then we need to pass in the directional input, right? So motion list, and we needed to get the current index, current motion index. Okay, and yes, is that going to work? No. Unreachable code in our input function. What did I mess up? Return false. We don't ever come here. Okay, so we're good. We don't need to return false. No, it's not good. Unused capture. That wasn't our component. How do we use oh, so we were looping through here. We didn't need to do that. We just need to do this. That's right. We aren't checking the current. We're checking what we're looping through. Switch must handle all possibilities. What is it? We mess it up? I thought there was a fall through thing. What does a switch fall through? I swear there was something. Yeah. Covers all values that are greater than da da da. Input does it. I thought this did it. What do we miss? I thought this fall through would work. Switch must handle all possibilities. Return switch. Is it because 5 is not 0 and 5 is not included? Let's just go The problem is that's I32. Let's do U32. Okay. Yeah, we'll deal with that here. Motion index. Sorry. Let's change. Okay, this is I32. Okay, got hungry here. Yo, what's up, Erebus Wolf? Does the switch statement order greedily check? I don't know. Yeah, I don't know at all, to be honest. It's all Greek to me. Okay. Yes, let's just change this to use. Oops. Oh no. Oh no. Oh no. Change those to use. It still says okay. What's the problem? Switch was okay. So if I start 0 and return false, and 5 returns false, anything greater than this should return false. Oop, not a comma there. I think this is how Zig works, or maybe I'm wrong here. Oh, switch. Okay, I'm gonna have to double check to see how switch works in Zig. Okay. Switch. Exhaustive switching. When switch expresses does not have an else clause. Oh, it must exhaustively list. Okay, there's a switch else. That's the thing. It's called an else. Okay. Whoops. Let's get rid of this. I don't care about that. Yeah, let's get. So you do. Well, how does that work with a return statement? Else. Oh, switch. Oh, that's how it works. So you don't do else here. This is confusing, a little bit confusing, but okay. So I don't need this technically, right? Yep. Okay. Still complaining about something. Oh, I need to have a semicolon. Attempted reference non-pointer type. Okay. What's the issue? Now it's saying a non-pointer type. Okay, I thought it was a non-pointer type. Oh, because I moved it. I don't know. Attempted reference non-pointer type. Oh, there we go again. Yeah. Alrighty. Okay, I'm just gonna. You know what? This is what this is for. Replace it with this. Okay. There we go. I'm much faster in doing stuff in Vim, but yeah. Okay. So attack comes out. So motion doesn't come out. I'm trying to do down, forward. Actually, yeah, we forgot one thing. I forgot one thing. I don't want to blame it on you guys. What I forgot was motion executed. No, we did call that. Okay. Let's make it longer. Just in case. I probably messed up something really obvious. So I'm doing quarter circle forward, quarter circle back. It's not coming out. Nothing's coming out. Okay, so I forgot something, clearly. Let's make it 30 frames, make it easy. Was motion executed? Now we're gonna have to check things step by step. So we know everything else works. We just know, actually this all gets used, so I don't need to do that anymore. I don't know if that makes a difference. We know everything else works because, again, if we turn this off, it just works, right? So the issue is potentially this. I think the issue is here. So, oh no, that's the issue. Yeah, put inside of here. It's actually needs to go up. Oh no, sorry. No, this is right. So every time we check, this goes up, and if the motion index is greater than the length, or greater than equal to the length, then we return true. Because yeah, we already got this all to work before, right? The issue is the check number pad stuff. Okay. Sorry, I'm getting kind of a stomach pain right now. Have you seen the Photon quantum networking solution for I've seen it before and I read the documentation, but the big thing with that is it requires you to implement their whole physics engine, I believe. They have like a different physics engine, so you have to kind of whole. It's not like a drop-in solution for Unity. You actually have to adopt their kind of deterministic physics. So if you want to use Unity physics, it's not a drop-in solution for rollbacks or other networking stuff. You really need to use their. If you want to have like rollback style deterministic networking, you have to use their physics engine. It kind of sucks. They might allow you to use your own physics, but it's not going to work with Unity's physics out of the box. If at least the last time I checked it. Yeah. Oh, I wish these pains would go away. It's very distracting. Okay. Anyway. So yeah, let's check. Let me check to see which where the problem's probably coming from. So the quickest thing to check to see is if we have like 1 left and down, 2 is down. Oops. 3 is right and down. 4 is left. 6 is right. 3 is right and down. That's correct. Probably just want it down and right way. So these are both input at the same time. And then 6 is right. So it should just work with the quarter circle forward anyway, because we did. It should be 2, 3, 6. What if we just did 2, 2, right? If we just do 2, 2. Actually, I know what the problem is. No, maybe. Yes. No, maybe. 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 I checked the motion list. Oh no, that's correct. That should be right. So that should be the right length. Yeah. What was our like logging printing debug stuff called again? Print, or is it debug? Common. Okay. Instead of Unity physics object method, to be honestly, I don't know if it even replaces. It might even replace the object model. I don't know. Erebus Wolf is asking, do you recommend a state machine to determine the input command and having it duplicate every frame part of the game state? I thought that was your approach, but have been chasing kids while I watch. I mean, it's definitely use state. When it comes to like supporting deterministic simulation with rollbacks, as much as possible, you want to avoid adding state, right? If you can kind of on the fly check the buffer every time. I'm not talking about performance here, but I'm saying if you want to avoid having state because you might introduce potential conflicts like, oh, this depends on what the state was a few frames ago, then you don't do that, right? But practically wise, what I end up doing for a lot of in a real game is I won't be checking the whole motion for. So I would only check the motion for every type of motion once every frame, right? And effectively what will happen is if that motion is still triggering based on a standard duration, so like all quarter circle forwards and all quarter circle backs in the game would be limited to say 15 frames, so it's consistent among the games, so you don't have each individual part in your code that's checking for a move to execute. You don't say, oh, this is 15 frames, but over here it's 20 frames. I do allow that for override, but for most cases, what happens is there will be a section of the input update in my game loop that will basically go through quarter circle forward. Is that active? Has it been active in less 15 frames? Cool. It's been active for 0 frames, right? Sorry, it's been active for 1 frame, or sorry, it's the most recent time it was activated was 1 frame ago, right? And if the next game update, if the quarter circle forward has not been detected within 15 frames, then that counter will tick. So okay, it was last found 2 frames ago, 3 frames ago. That's convenient because instead of like actually checking the motion every time in each section of the code, you might like, okay, well, if this quarter circle forward was valid 5 frames ago, it's fine. Yeah, let it go, right? That lets you add like buffer times to individual cases for state transitions without having to check the whole thing. So when it comes to say state machine, yeah, there's in the sense there is state. I wouldn't call it a state machine though. Yeah. I hope that answered your question. Okay. Sweet. Vision Gap was asking if I would use their API for the phone quantum. No, I would not use their API. It might be if you have the money and kind of like the budget to spend time investigating that kind of thing, and it looks like it's better than implementing your own solution, yeah, go for it. But typically, the kind of games I make, I have like very strict kind of rules about gameplay behavior, and it almost always requires implementing your own kind of physics and collision and stuff like that. Um, Again, I'm mostly working on like retro style games that have very like arcadey style physics and gameplay rules. Cool. So yeah, I wanted to add a little debug here to see what the heck is going on. Why is this not working? So let's see if we actually detect any motion here, right? So let's say detected input direction, motion direction. I don't know. And I forgot how to actually do format printing. Oh, do we even have format printing here? Message. Oh, S for string, maybe I for int. I don't know. Let's guess. Oh, I have the wrong input system here. Whoa, my brackets are gone. I think I'm in English mode. Oh, there we go. Okay. I think if I just put in like motionless current, is that gonna work? Detected motion direction to, oh, I forgot the end of line. So I detected 2 and then nothing else. That's interesting. So I detected 2, and then it should have went on to the next index. So current motion index should be motion index plus 1. It should come around and detect the next one. Why did it fail? Let's do it again. Yo, what's up, Comic Man? Nice seeing you. So it says detected motion direction 2, and then it didn't detect anything else. That's so weird. If I just do, yeah, 2 gets detected every time. Down 4 doesn't get detected. So what's going on? Oof. Well, let's just dump checking motion direction and see what that does. What are we checking? So we're checking 3. So 3 is failing every time, as you can see, right? So why is it failing? Is it because this function? It has to be because of this function, right? This function is not working. So let's see. Maybe input command is wrong. I don't know. Let's see what's going on. Okay. Stream's going a little long today. We're at 1 hour and 30, but we should be close to making this work. So 3 should have been right and down. So for example, if I do, let's make everything just down. Does that make it work? Just as a conceptually, I'll undo this real quick. So in theory, if I hold down and press the button, it should come out now. In theory. And it does come out, right? What if I just do, leave these as down? Does it detect right? No, it doesn't. So there's something about this that's not working. Okay. What if I just check right? Does just right work? So right is not working. Is it because I'm not recording it? Is it because I'm checking forward and back? Maybe that's what's going on actually. So let's change this to dot right to dot forward. Maybe I have something just left in there. And then let's say dot left is dot back. Maybe that's the issue. Maybe I'm not even recording left and right now. Oh, it's coming out now. Quarter circle forward. Quarter circle back doesn't do it. Quarter circle forward does. What if we change it, our input command now to a different direction? So, where is it? Common states? Common states. Alrighty. So we have quarter circle forward here. Let's change the quarter circle back. I wish I had a camera like on my keyboard so you can see me doing the inputs. I guess you can do it. You can do it with this. So I can like invert. I can show you that it is in fact working. Right. So quarter circle forward. I just changed it to quarter circle forward, and it's not updating in the game. Oh, there we go. So quarter circle forward doesn't make it come out. Quarter circle back does. This is quarter circle back because it's going to the left. And if I jump over, it should just work. Yeah, it just works. Quarter circle back works. So I had to change the direction. Oh, quarter circle. Yeah, there we go. Quarter circle back, quarter circle forward, quarter circle back. And then check the dragon punch motion just for posterity's sake. I don't know words. I might be using the wrong words. But so, okay, dragon punch. Go forward, down, down, forward. It's kind of quick, but it is working. Quarter circle, well, quarter circle at forward is actually making it come out. Probably what's happening is, oh, I'm not, sorry. There is a problem. I need to make sure that the left and right is not being pressed for this kind of directional check. We can fix that real quick. So it was good that I checked the dragon punch, right? So I don't know if it's obvious what's going on here. Down doesn't care whether or not you're pressing forward or back. It will come out either way. So, and the same with forward. So if I'm pressing so dragon punch input it's a 6, 2, 3. That's the order, right? So this will actually currently activate whether or not you're pressing down, forward, or forward, right? So if I'm doing a quarter circle forward, well, it's going to detect that on the down forward. And, well, 2 shouldn't come, no, 2 will come out because I'm holding down forward still. And then I do 3, which is forward. Oh, sorry, yes. So I'll do 3, which is also breaking. So it'll come out if I'm just holding down forward. So that's actually a mistake. We need to make sure that the other inputs are not being pressed, right? So, for example, down would need to be like this, and then something and not. I think it's and not. This will work. Input command dot left or input command dot right. So this will make sure that you're not pressing down or left or right, right? That should work. And then forward should have a similar kind of logic, right? Where it's not, instead of left and right, you don't want to be up or down. There might be cases where we want to let it work, but for the simple example, that's not the case. So so this is back, right? So back we don't want to do up or down either. So sorry, this is a mistake. 3, ooh, 3 shouldn't have been that. Sorry. 3 should have been what? Oh, actually 3 is not forward. What's going on? No. 3 is sorry. Should be forward and down, right? Same should be 1 where it's back and down, forward and down. But we want to double check this. So down, back should be same as forward. My brain, I'm reading this and not looking at I should be looking at the numbers. So what happened here is 2 should be this up, this down, up should be similar. So up is this, it should be like this. It should be and not . Okay. And then forward should be kind of similar. This is back, so not left and right, but down and up and down, however you want to go about it. Forward, 6 is forward, right? 6 is forward, so you want to check up and down as well. So that's where this goes, down and up and down. Up, down, left, right. So that's really the order, but and just to be consistent, I'll do that up and down. So that will check that. And let's go through all this. And these like cardinal directions, let me make sure you're not pressing any other directions. I could be more precise with these other ones, but you technically on a keyboard could be pressing opposite directions, but you can filter out for that as well. For now, that's a whole other topic to get to. how your game handles left right inputs being pressed at the same time or up down inputs being pressed at the same time. That is not our main concern right now. So 7 is to be backing up. That's right. 9 should be forwarding up. Everything else should have a knot on it. Cool. So, ooh, I got a. It's not knot. It's this. I'm thinking Lua right now. So it needs to be that. I thought it was a knot, but it is in fact exclamation point. My brain was very much in Lua mode because of the and name. Okay. Okay, Dragon Punch doesn't come out. Oh, no, it does come out. I have to be precise. No, I actually have to be precise. So I'll show you that. So, yeah. Oh, no. Oh, no. Get to get the game up. Okay. So if I'm over here, I'm walking to the left, and then I do down, down, forward, and Dragon Punch comes out. Walking. That's what we want. Same. Walking forward, down, down, forward, Dragon Punch. You can do walking Dragon Punches with this now. Sweet. Now this is double check our quarter circle forward and back just to kind of give us a kind of exhaustive check on everything. Yeah, that was in our common states, right? Common states. So DP quarter circle forward. Let's do that. Ooh, not that. Okay, that's fine. Ooh, 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 ooh. I'm pressing buttons all over the place. Okay, so ooh, ooh, ooh. So I'm doing quarter circle forward. Comes out. So in the same way you can do walking Dragon Punch, you can hold down for fireball motions, and then just roll forward, and then you get the fireballs you see. And if I do the other way around, right, it shouldn't come out. And if I do a Dragon Punch, it shouldn't come out. Except it did come out. So I probably messed up something there. Let me try the keyboard. So it's coming out on fireball's coming out on Dragon Punch. There's a way to avoid that. Probably what's going on is that final input check is F6 is being detected when it shouldn't be. 6 should make sure down forward is not pressed. Let's see. What do we miss here? Let's go through real quick. 6 is forward and not up or down. So if up is true or down is true, this should never be true, right? Or I'm crazy. So down forward, which includes down, should never give us the valid check for 6, but it is. What the heck? What am I missing? No, sorry. It's just 3. That's right. Wait. Quarter circle forward should be 2, 3, 6. 6 is... We're getting... So I think what's going to have to happen... It didn't come out that time. Maybe my inputs were just sloppy. I don't know. So if I hold forward... Oh, okay. Well, at least it's coming out when you do quarter circle forward. There's probably something sloppy with the way we're recording the input that's making that happen. I'll have to add some like buffer debugging for us to easily find it. But pretty much this is like where we wanted to be at the end of the stream, I think. I had a few other things I wanted to kind of cover about like how we can improve it. Things like that, how performance. I did talk a little bit about what I would actually do in a real implementation of this, because Erebus Wolf had asked. But yeah, I mean, if anybody has any other questions, I'm happy to ask them. Otherwise, I'm going to prepare to finish up here. I'm going to go ahead and just like submit the changes we've done. We made quite a few changes to a lot of files. See modified here. All right. Yeah. So let's go through all the modified ones and add them. Component. Character data. Yes, we did update that. Technical design. I'll do that. Okay, character changes there. We added special attack animation. Technical design, I'm gonna update that. State needs to be updated. Comment states need to be updated. I think that's all. These are things I'm not worrying about because these are just these are documentation things that I will update later. Okay. All right. So added support for special move input motions like cursor forward, cursor back, DP, etc. I think I got everything right. Build. Is there a change to build? I don't know if that's needed. If anybody has an issue building this, let me know. You know, I'm just gonna submit that. I don't know why. Anybody runs an issue, let me know. I don't know if that's needed because I don't think I'm linking it to C, any kind of C libraries right now, but maybe I am. Can you explain how the buffer works in general, like how you would change how large or short the buffer window is? Were you able to see the whole stream? I did go over the general concept of it a bit earlier, but in short, I'll just walk through one more time, right? Originally, we only had 2 frames of input, just a sequence of all our on and off inputs, right? We had 2 of those recorded once per frame, but it wasn't enough for us. It was good enough for us to do like detecting whether a button was pressed or released, but not good enough for detecting a sequence of 3 or more inputs. And so I proposed, hey, let's add for like a quarter circle forward motion, which requires 3 inputs for down, forward, forward, or 3 sequences of inputs. What if we suppose we had 3 sequences? Sorry, we had a 3-element sequence of directional inputs. That's good enough to detect it, but it's too difficult as a human being to actually execute at 60 hertz or 60 frames a second a perfect in sequence 3 directional changes, right? So the next step was, let's increase the buffer size enough so that we have a good enough leeway for players to actually change their input without having to go too fast, right? And so we increased the size to an appropriate amount, which is just something you get by testing and finding out, well, is this too short for people? And also you added the concept of a limit on how many frames you allow somebody to input this motion. In our case, I think I put things at 15 frames as just a placeholder. I can show you here probably. Well, here's 30 frames, so it's pretty long. I think 30 frames is a little too long for quarter circle motion, but yeah, I guess it depends on the game. And if you make it longer, you'll get the motion come out more often, but it will come out in times you don't really want it to come out, just by accident, just by walking forward and crouching and such like that. And there's one more thing I didn't really implement this time, which is a did it come down here? Yeah, I didn't implement a charge. Sorry, I didn't implement a charge input, which is kind of the opposite. Where you, instead of putting a limit on how long you have to input a sequence of directions, you actually put a minimum amount of time. So you have to hold back for a certain amount of time before you press forward. Right. So for an example, like if you're thinking of like a Honda's headbutt in Street Fighter 2, you hold back for a minimum amount of time, then you hold forward, or you press forward and then a button, right? And if that the direction holding back was at least for a certain amount of time, and then that forward press plus button was within a time limit, right? Then you get the motion. But yeah, I hope that's explanation enough for what you're asking. Yeah. Is there any other questions? Otherwise, I think I'm going to shut on the stream here. I got a little bit of a stomach pain, probably just hunger, but I'll take care of that. Well, anyway, pretty long stream, but I think we had a pretty exhaustive coverage of, special move motion inputs and how to handle input buffering and detection there. I think next time, what did we put on our list of things to do? I think I had implement special attacks. Cool. Yeah, so there's not an exhaustive list of things I want to do going forward, but I'll come up with something for the next stream. I have a big list of stuff we have to get to. So until then, you know what? I appreciate everybody coming by and watching, and I hope you learned something. If you didn't, I think a lot of stuff, if you're a fighting game player, you're aware of. If you're very technical, you know how this stuff works, but at least I've kind of recorded this stuff on video for y'all. If you want to go back and like, okay, how did it actually work? Okay, oh, you could do it that way. Cool, awesome. It's a good starting point at least. But yeah, again, thank you. I'm gonna head out. Until next time, have a good evening. Have a good morning wherever you may be. Peace.